In this video, I'm going to show you how to make a keypad that requires a 4-digit passcode. This scene that you're seeing right here is remixable, and the link is in the description, and I would highly recommend you clicking it and checking it out, as opposed to trying to build this from scratch from this video alone. So here it is. I know the passcode. You can set the passcode to whatever you want. Not in-game, you'd have to go into the logic. And if you do anything else, it says incorrect. But if you type in the correct code, which happens to be 1234, it says correct. And again, you can change what is the correct code in the logic. So let's check out the logic. First, we're going to go over the buttons. This is probably the easiest part to understand, hopefully. We have an animation, and this animation, is just the press animation. I didn't play a sound here. You very easily could by just putting a sound in the timeline. What is this? This is sensing the grab, your imp's grab. Are we hovering? We could hover. You could maybe highlight it a little if it's being hovered. I opted not to use the hovered output. I just checked if it's grabbed. So if it's grabbed, it pulses. And what is it pulsing? It's pulsing on this node. What does that mean? It means whatever signal's going into it is allowed to pass all the way through. What signal's going into it? 1.1. What does that mean? Well, this is the 1 button. What value do I have for 2? 1.2. What value do I have for 3? 1.3. Are you sensing a pattern? What about 0? What value do I have for 0? 1.0. The reason we do this is because Dreams is not able to transfer a value of 0. It just thinks it's off. So instead of transferring a value of 0, we do 1.0. In normal programming, variables can be 0. Numbers can be 0. And then if there's no value, it's null. In this, 0 just is nothing. So to differentiate between nothing and pressing the button 0, we send the value 1.0, 1.9, 1.5, etc. What would be clear and enter? Okay, so yeah, I forgot how I did this. 1.0 and 1.0. Why do we do that? Well, clear and enter are hooked up to separate things. So here is where all the values go. Here is where clear goes. Here is where enter goes. So it just needs to be a value of 1. I guess you could just wire it all into the same, but no, that doesn't make sense. So that's the next thing though. So this value is allowed to pass through in a pulse. So it's being pulsed. Where does it go? All of the number values go through this node. And then this logic handles like remembering which number you typed in. How does that work? This is probably the most complicated part of it. It's not that complicated. It's just, I don't want to say convoluted. It's just an interesting solution, I guess. I needed a way to basically save 4 numbers. And then when one number is entered, I need to like go to the next number. And the way I did that was I'm going to call it a custom selector. So this timeline with nodes in it functions as a selector. What I'm doing is moving the playhead. I'm moving the playhead depending on what this counter is. Okay? Every time I enter a number, this counter counts up. When this counter counts up, the next node turns on. See? Why are these, what are these nodes doing? Well, notice how this number, or the number that you enter, which all of the numbers we enter go into here. Wait, I have already said that. And then this goes into all 4 nodes. This goes into all 4 nodes, but only one node is on at a time. Where do these nodes go? Into the 4 chips. Each one of these chips saves the value. So let's play it. Value 1, value 2, value 3, value 4. Obviously, it doesn't have to be 1, 2, 3, 4. that won't work. But so 9 is value 1, 8 is value 2, and then et cetera, et cetera. So those 4 chips are saving those values. How does that work? It's pretty simple. I could have done this a bunch of different ways. I chose to do a looped calculator. So if you didn't know, a looped calculator will save whatever value is in it. So basically how this works, 0 plus 0 equals 0. If I enter a number into here, that number plus 0 equals that number. That number plus 0 equals that number. And it just keeps looping around. So that you can think of that value being stored in this wire kind of thing. And because we're pulsing that, so let's say like the number 1 was input to this every frame. It would keep adding 1, 2, 3, 4. But since we're pulsing that number, it just gets added once and it saves that number. So we can actually see this, right? If we, I said the value 1. So we enter 1. First, you'll notice that this node is no longer on and this node is now on. But that value 1 was indeed passed through this node. How do we know this? Because look, see this wire? It's lit up. Guess what value is here? 1.1. Okay, 1.1. We're just gonna pretend it's 1 though. The 1 value is in there. So let's restart. What if I type 9? What do you think it's gonna be? It's gonna be 1.9. See? 1.9. So that value was passed through that node into this node and pulsed, by the way, into B. So if we play time, it's still going to be 1.9. And it's being stored in here. What if we clear? What happens when we clear? This timer gets reset. Oh, really quick though. Why is this a switch? Clear, reset values. This keyframe powers this switch on. Literally the only reason I did this was so I don't have a bunch of wires going into these. You could very easily just do this, right? But I opted to do the keyframe powering on a switch. I don't know if I can demo it, but like, bam, see? So, and then the clear button, no, that's not it. The clear button is hooked directly up to that keyframe, which resets this timer. What does that mean? The timer resets. What's happening? When the timer resets, the timer is no longer finished, which powers off this calculator. When a calculator is powered off, all values in it are reset to 0. So that's how you reset it. You could have saved this number differently. It could have just been a variable. You could have just saved it in a variable. I like this solution better because you don't have to rename it if you copy and paste it, like you do with variables. And it's the same with all of these. So I'm just gonna keep demoing it. Hopefully everyone understands it. But if we play time, so let me go through it one more time. We play time. This node is on. Why is this node on? This counter is 0. Right? This counter is 0, which puts the playhead here, which turns this node on, which makes it so whatever number you type in, the value goes through this node, which goes into this chip. Yeah. So what happens when we press a button? How about 2? This counter counts up. The timer plays, it pulses this counter up. The counter counts up. So it's 1 out of 3. What does that mean? The playhead is now here. So the next value you type in will go through this node. And then the value 2 was passed into here, 1.2. Now this one is the next one. So if I type in another number, how about 3? Counter counts up again. Now it's 2 out of 3. The playhead's here, so the next value is going to go through this node, and the previous one went through that node. The previous one was 3, 1.3. Okay, hopefully that makes sense. How would you make this a 5-digit passcode? It's really, really simple. Copy and paste that. Add another node here. Increase the counter by 1, like that. That's it. So now it's 1, 2, 3, 4, 5. Is there anything? Is there anything else? No. That's literally. I mean, okay. Obviously, the check code logic would need the check for a 5th value, but that's literally all you have to do to extend the code, to extend the passcode. So I'm gonna undo that though. Hopefully that makes sense. I really hope that makes sense. If it doesn't, ask questions in the comments. And everything else after that is easy. That was the hardest part to understand. Now we still have to go over the easy part, so let's do it. The values are being saved in here. Now it's not like the actual number though. It's 1.1, 1.2, or whatever. So now what? How do we display the values? Pretty simple. We need to convert it though, right? So this chip does 2 things. 1, it converts the value to the actual number. And 2, it turns on the number displayer if there's actually a value. So how do you convert the value? You just subtract, or what do you do? Oh, yeah, that's right. So 1 is 1.1, 2 is 1.2, right? So to convert it, we multiply by 10 and then subtract 10. So what does that mean? Let's get a calculator up. 1.1. How would we get this value? Well, multiply by 10, subtract 10. There's your value, 1. Well, how about 1.9? This is the last example, don't worry. 1.9. Multiply by 10, subtract 10. There it is, 9. So hopefully that makes sense. If it doesn't make sense, think about it, I guess. Okay, and finally, when is this turned on? Well, if it's greater than 0, it turns on. That's it. So if there's no value, it's off. And you can clearly see how that works here. It's off, gets a value, it turns on. Gets a value, it turns on. So that's a bug. Okay, we fixed that. So that was my bad. I forgot to basically stop inputs from happening once you are full. How did I do that? I extended the timeline by 1, and I extended the counter by 1. So let's do another demo. Notice how it doesn't happen anymore. Why doesn't the bug happen anymore? The timeline is now here. No nodes are on. So even though values are coming in, no nodes allow the values through. So none of these get updated. What was happening was the value kept being added here, which is pretty funny. But yeah, so that's fixed. Sorry about that. Anyway, so that's how the numbers are displayed. And finally, how do we check if the code is correct? Well, we have the numbers we typed in. It's as simple as you would expect. It's literally just sliders plus 1. Remember, because we have to convert these to 1.1, 1.2, etc. So it's the number. Well, okay, it's 0.2 instead of 2, but it's just easier to move sliders. Yeah. Anyway, so it's 0.2 plus 1, and then it's just checking if it's equal. You can see how the code was set to 1, 2, 3, 4. Let's set it to 1, 1, 1, 1. Notice how that immediately works because I have 1, 1, 1, 1 typed in. But if we reset, that doesn't work. For example, that does. Right, so it checks if they're equal, puts them all in an AND gate. If this AND gate is ever true, nothing happens. If the AND gate is false, nothing happens. Why? It's passing through these nodes, right? When do these nodes turn on? These nodes have to turn on to allow the signal to go through. When do these nodes turn on? Bam, enter. You have to press the enter button. You don't have to do that. You could check if all 4 numbers have a value. Literally, all we need to do is pretend. So like, we need to pretend like the enter button was pressed, right? So, I mean, let's just pulse this value, right? Pulse this value into that node. I haven't tested this, but I'm very confident this will work. See? And I don't actually know what happens. Oh, yeah, there you go. So if you wanted to auto submit, that's how you do it. And honestly, you could just disable it. You could get rid of the enter button completely. Because now it auto submits. Last thing, how do we display correct or incorrect? I mean, when it's correct, right? A value gets pulsed out of here, and when it's incorrect, a value gets pulsed out of here. We literally just play a timeline. Prevent input. Okay, sure. So I have a key. It's displaying the correct text displayer, and I have a keyframe that I believe. Oh yeah, it turns off this node, which stops any inputs from being typed in. Otherwise, you'd be able to type in inputs while the message was being displayed. That's it. That's how it works. Hopefully that makes sense. If you need additional Dreams help, I stream Dreams on Tuesday, Wednesday, Thursday, and Saturday. And I also have a really awesome Discord community where you can just ask any Dreams questions at all, and someone, it might not be me, but someone very smart will help you. And of course, you could talk about Dreams or pretty much anything there as well. But yeah, guys, that's it for now. I hope you enjoyed the video, and I hope you have a great rest of your day. I just wanna be with you. I just wanna